Hi, welcome to our discussion of different types of hygrometers. We're looking at humidity measurements and we're working our way through all the different types of ways that we can measure water vapor in the atmosphere. And we're going to look at the procurement of a vapor liquid or a vapor solid equilibrium. And this is commonly known as the dew point or the frost point hygrometer. And what the dew point hygrometer does, well, it figures out the dew point. Pretty unique. And it's a neat device in that it's one of the only true devices that actually figures out the dew point, believe it or not. All the other instruments we talked about, you evaporate water into the air, or it's based on the absorption of a certain amount of water vapor and figures out relative humidity. But this actually does figure out the dew point exactly. And it does it by using a polished metal surface that is, it's heated and cooled in a cycle using the Peltier effect. And we'll talk a little bit about that in a second. But there's a temperature sensor that's embedded in the back of this mirror. So as you cool the mirror, you know the temperature of the mirror. And as you heat it up, you know the temperature, of course. So the Peltier effect was discovered by Jean Peltier. And he found that you can heat things and cool things by using two different metals and sending a voltage through them. And as a result, you get heating on one junction and cooling at the other. So it's opposite of the Seebeck effect, which we've talked about already. So as I said, when you pass a current through two dissimilar metals that are connected at two junctions, then depending upon the direction of the current, you get heating on one end and cooling on the other at the junctions. So believe it or not, this is how many of our small cubic refrigerators work, kind of dorm room style refrigerators. I found that out when I tried to fix the compressor on one that we had in our lab and realized that, hey, there's no compressor. They did away with compressors and they used Peltier effect. So the Peltier effect actually cools the mirror. They have a diode that shines, a light-emitting diode that shines on the mirror, and then it bounces off at an angle to a detector. If there is dew that forms on the mirror, then the light won't reflect. And as a result, it measures the dew point. It can figure out when dew forms on the mirror. And using that little embedded temperature on the back of that mirror, it knows the temperature that the mirror is at. And from that, it figures out the dew point. So it does this very rapidly. It heats up the mirror, the dew evaporates, and then it cools it, and then you get more condensation on the mirror. And then the light emitting diode realizes that it can't reflect off the mirror anymore. So it does this several times. In a second, it does it several times a second. I'm not exactly sure the cycles per second or the hertz of the system. So that's how this works. It tries to maintain a constant dew layer that's controlled by this feedback mechanism of the temperature of the sensor being fed, the current, having a current going through and causing the heating and cooling through a Peltier effect. So this is probably one of the best instruments for figuring out the actual dew point. There's also a frost point hygrometer, which is looking for frost forming on mirrors, and it uses a device that cools the mirror a little bit more at colder temperatures. So the advantages of the dew point or the frost point hygrometer: it is one of the only instruments that measures the dew point, actual dew point. So that's why it's called the dew point hygrometer. It's probably one of the most precise methods for figuring out water vapor in the atmosphere at relative humidities above 5%. It's got good calibration stability, and of course there are no moving parts. Now the disadvantages, and we had one on our research aircraft, and I can account for these disadvantages. Number one, the mirror, you assume that the mirror is the same temperature as the air temperature, and that's a pretty good guess. But other problems, it does not have a very good response rate. In other words, the time constant is like 2 to 10 seconds, which is not bad if it's stationary. But if you're flying along in an airplane and you're moving at about 180, well, maybe a little bit less than 180 meters per second, maybe more like 150 meters per second or 120 meters per second, then you're going over about 500 meters, and by the time it responds, so you're not getting very good response, not good resolution of the phenomena that you're looking at. Typically, clouds are about 500 meters across, so by the time you enter the cloud, you can see the dew point hygrometer reacting after you exit the cloud, which is really strange. So you keep that in mind. Another problem is that if the dew point hygrometer is outside, then it tends to collect dust. You have to keep the mirror clean, have lots of Windex handy. They don't really use Windex, I just said that. So it does require frequent cleaning. As a matter of fact, this was the instrument that was used to figure out the dew point on ATSC stations up until about, I guess, 2007, when they switched over to the high capacitance type hygrometers that we talked about in a previous one. And also, if you're right at 0 degrees Celsius, you're not sure if it's dew or frost that's forming. So that is a little bit about dew point hygrometers.